content of this yeah, Robin.
Is clear skin and clear audio.
Okay, thank you. So the content of this presentation is basically we will learn something about what is the load balancer and what is the core concept about the load balancing, why we need it and all this stuff. And after that, how we will learn about how load balancing works. And after that, type of the load balancer, then the load balancing concepts, what are the keywords, what are the terminology that is being used. And after that, we will jump directly to hands-on lab. And as I have already mentioned, this is not a detailed overview about the load balancing. So we will go through some of the basics and we will try to cover as much as that is required to the hands-on lab. Okay, let's begin. So what is the load balancing? What the term load balancing actually means? Basically, load balancing service provides automated traffic distribution to one entry point to multiple server that is reachable. So basically what it does is you will have a one single IP address, and at the backend there are multiple servers, let's say if you have a web server, then you will have a one public IP address of the load balancer, and at the backend there could be multiple web servers serving for them. So the main advantage of having a multiple server is that there is a high availability. If any one of the server goes down, then your service is not impacted. And the second advantage is it's scalable, right? So if you have a high volume of load, then you can add more servers and make a member of the backend. So once you make a member of the add a server and make a member of the backend set, then the traffic gets served by the new servers also. So for that, you do not have to change any of the things. And another advantage is that you can scale up and scale down at any time, and you have a proper resource utilization. So that means if you have a two servers, one have a low resource and another have a high resource, then you can set a policy so that the server with the high resource get more traffic than the server with the low resource. So basically a load balancer improves resource utilization, facilitates scaling, so scaling in terms of scale in and scale out, and helps ensure high availability. And the another things about the load balancing is it is a custom application. There is a custom application specific health check to ensure that the load balancer directs traffic only to the healthy instance. So that means that if you have a lot of backend server, then there is a chance that one of the server may get faulty, and if your load balancer send traffic to the faulty server, then your request could not be solved, right? So in that case, there is a specific health check. We can have a custom health check script that will check the health of the computer instance, health of the server, and if it found health unhealthy, if it found faulty, then it will stop sending traffic to the unhealthy one. So this way we can do a health check from the load balancer also. And the load balancer can reduce your maintenance window by draining traffic from a unhealthy application server. Let's say if you have only one web server, and if you need to apply patch and bounce it, or you need to do some changes on the hardware itself. Let's say if you need to add a RAM on it, memory on it, then your application get down, right? Your application could not be served. And if you have a multiple server serving the same application and you have a load balancer in front of them, then you can get down the one of the server, you do a maintenance and get up that one server. And if you are done with the one server, then you can do the same, repeat the same thing on another server. So this way we can reduce the maintenance window by draining traffic. Basically draining traffic means marking it as unhealthy and stop sending traffic to the unhealthy application server. So this way we can reduce the maintenance window. And how the load balancing works. A public load balancer, there are two types of load balancer, public load balancer and a private load balancer. A public load balancer has a has a public IP address that is accessible from the internet. So basically, you may have a lot of bunch of web servers or any sort of the server application servers that is sit behind the load balancer, and you need to have only one public IP address for the public load balancer, and you will get access to the service. And in case of a private load balancer, there is a one private IP address that is being used from the internal subnet and can be visible within your VNC only. So in case of a public private subnet, in case of the private load balancer, it cannot be accessed from the internet. And there is a listener for the IP address. So basically, the IP address that is being used for the load balancer has a listener. So basically, listener means it is a layer 4 or layer 7 port that is being solved, that is being ready, that is being in the listen state and is solved for the client. So basically, both public and private load balancer can route data traffic to any backend server that is reachable from the PCN. So if you have a compute instance that is defined in the PCN, then if they are reachable, then load balancer, public or private load balancer, can send traffic to that server. Okay, this is the type. We have a two type of a load balancer right now: public load balancer and private load balancer. In case of a public load balancer, a user sends traffic to public load balancer by internet, and the public load balancer routes the traffic to the healthy compute instances. And in case of a private load balancer, there is a user that sends the traffic to the middleware, some sort of a middleware. That could be the web server or some sort of middleware. Then the middleware within the PCN will send the traffic to load balancer, private load balancer, and private load balancer will redirect the traffic to the database instance. And the public load balancer is used mostly in the case of web and all this stuff where the access from the internet is required, and the private load balancer is used for the high availability of the services or the server that is required within the VCN. So it is not accessible by public, but it is required by the middleware or can be used by the internal servers. So there are few concepts that is being used in the load balancing. There is a backend servers. So all the servers that is being hosted that has a some application hosted is a backend server. Let's say if I use a public load balancer for the web services, then all the compute instance, all the servers that is hosting web servers are the backend servers. And we have a backend set. So it's basically a group of a backend servers that we call as the backend sets. And we have a health check script that will determine which backend server is healthy and which one is not healthy, which one is unhealthy. To mark this state, we have a TCP label. So basically TCP layer 3 health check means it works on the layer 3 and it works with the TCP and its port. And we have a STTP that is basically layer 7 health check. It's work on the STTP or STTPS level. It's works on the application level. So after that, we have a health status. So on basis of the health status, the load balancer sends a routes or traffic to the backend server. So we have a OK state. OK state means that the server is OK and is able to serve. And warning is the some sort of the issue has been there. So it's in the warning state. And we have a critical state where the server is in critical state and are not able to serve at all. And we have an unknown state. So basically unknown state happens at beginning when the health check has not been performed. So basically one, again to the first, again second, third. So it basically works on the round robin fashion. And second policy we have is a list connection. So in that case, the listener will determine which server is most free, which server has do not have a huge request, basically active sessions. So the server with the least active sessions get the request, and all the request is route to the server with least active session. And another, the last one is the IP hash. So basically in this case, it will calculate the hash, it will make a hash value, and it will send on basis of the hash value to the, it has some internal mechanism to calculate hash value, and it sends that, it routes the traffic on basis of the IP hash value. And there are two type of load balancer. It's a public load balancer and a private load balancer. Public load balancer is visible to everyone in the world. So basically you can access the public load balancer via internet. But in case of a private load balancer, it is only accessible to the compute instance and the services within the VCN. So let's jump to the hands-on lab. Do you have, if anyone have any question, just you can type it on the chat section. So for hands-on lab, we have, okay, it's again the same one. Okay, I hope everyone can see the hands-on lab guide and my Chrome window, right? Excuse me. Okay, at first we will log into Oracle Cloud console. So for that we will open oracle.com/cloud/signin.html, and we will provide the tendency name over here. So basically cloud account name is the name of the tendency. In this case, we have a Cloud Nepal as a tendency. Just type the tendency name and click on next. So after that, you will be prompt for the username and password. Provide your username. It most in the most case it is your email address and the password. Just provide the username and password and click on sign in. And once you have signed in, click on navigation menu. Navigation menu, then networking and a virtual cloud network. We'll go with the start VCN wizard. Basically, we will go with the easy one. So and select the VCN with the internet connectivity and click on start wizard. We'll provide the VCN name. It's a VCN 0001. You can put 2 zeros. And we will review the rest of the things, and we are perfectly fine with the all the default configuration. And so we will just click on next. So it asks us for the final review. We are perfectly fine with all the settings. So click on click. Now my VCN is created. I am able to see the VCN details with the view virtual cloud network. And here is the detail of the BCN I have just created, BCN Z01. Okay, we will have some 5 to 10 minutes pause so that everyone could log into their console. So let's begin to log into console and create BCN. If anyone have any issue, then just let us know. Romin, Asif is asking for the document URL. Can you just
Yeah,
provide him one second? I think everyone is able to download the hands-on lab guide we have prepared, right? Romin, I will create a public.
I try to get public, but it's not done.
Okay, so let me create the one.
Can
I have
you-
created the publicly accessible URL. So if you provide this one to
Sure, sure.
anyone,
Okay.
then anyone can access it. But I am not able to type anything on the chat window.
Send me in WhatsApp. I'll send it.
Yes, sure. Okay, I have just sent it to you.
Okay.
Robin, I'm sending second. So if anyone is able to complete till the creating BCN, just type completed in the chat section so that we can move ahead. Or if anyone is having any issue, just type. Thank you. Thank you, Keshav. It's a pretty simple step, right? If you have access to the cloud console, Oracle Cloud Console, then just click on the navigation menu, then click on network. So let me repeat again. Click on navigation menu, click on networking, then click on the virtual cloud network. So it's always easy to go with the start VCN wizard. Wizard is very easy one. So just click on VCN with start VCN with wizard. Then by default it will get selected VCN with the internet connectivity. Just select the as it is and click on start VCN wizard. Provide the VCN name. Just type next. It will ask you to review. If you want to review, just go for the review, and after that click on create. So we have Suruchi, we have Raju, we have Keshav. We have completed. Guys, if you have any issue, then just let us know. Okay, we have Asif done, Ujjwal done. Okay, let's go to the second step. Let me delete the second VCN I have created. Okay, after that we will create a compute instance to host our web service. So we will create a compute instance with a web server installed on it. Let me complete the termination of the second VCN. Yep, it's done. So for that, just click on the navigation menu, click on compute, and then click on instance. Right now I have two terminated instance. So just click on create instance, provide the name of the instance. In my case, I am happy with the web one. Compute ISO image is operating system image is Oracle Linux 7.8. You can select any flavor of the Linux. In my case, Oracle Linux is perfectly fine for me. And safe networking and storage. In case of a safe storage and networking, I'm using this always free eligible safe with the 46.6 GB of storage, and it has a 1 GB of memory. Just paste your key over here. So in my case, I have a key ct.sss get id rsa. This is my SSH key, so I'm going to copy it, paste over there. Click on create. I'm doing the same things for the second instance also, so just click on create instance. My second instance name is web2. Everything is fine for me. Just paste the SSH key and click on create. Now it is in the provisioning stage. So it's basically building right now. And once it is up and running, we will configure our web server over there, and we will access it by browser. So to access the compute instance, I am using the Linux terminal. So this is the command to use. This one is the command to log into your compute instance if you are using Linux, and if you are using Windows, then you need to use a putty and type your IP address over here, name of, you can provide the name over here, and you need to click on expand the connection, then SSH, then you need to go to the auth and browse your private key over here to connect. And after that, you can save the session and click on open to access the compute instance. So in my case, I am happy with the Linux one. Okay, it is still in the provisioning step. Now it is provisioned and I can access it by terminal. So SSH OPC, the username should be always OPC, Oracle Public Cloud, and the IP address, just IPS, and you are in. So in the same way, let's access the second server, SSH OPC at just IPS, and you are in. After that, once you log into the server, then you can install Apache. You can install Apache with the yum install httpd. Then you need to start Apache, enable it, and load it into firewall so that the port is get allowed. And after that, we will create one index.html page. So let's do it on the web one. Just copy everything and just paste over it, and do the same on second server. Yeah, if you notice, the Apache package is downloaded and it get installed. After that, it get enabled, it get started, it get enabled. The firewall rule is being added successfully. Firewall is reloaded, and the index page, this is web one, is being created with the content. This is web one being created, and in the same way, we have a web two where Apache is installed, Apache is started, configured, web server is configured, and then firewall port is open, firewall reloaded, and we have a created one index.html with the content. This is web 2. Okay, after that, we need to allow the port 80 in our security list. For that, we go to navigate menu, then network, then virtual cloud network, then click on the VCN you are using, then go to the public subnet, then click on security list that is being used and add a ingress rule. For that, just click on navigation menu, networking, virtual cloud network, click on the VCN name, click on the public subnet because we are using it for the public purpose, right? We are going to access it via our browser. So public subnet, then click on default security list, then add ingress rule. Means ingress means rule 2 for the incoming traffic. So since we define it as a stateful, not this stateless is not being selected, the traffic flows to into the compute instance and out from the compute instance. Basically, source CIDR equals to 0.0.0.0. So that means anywhere from anywhere. Protocol that is being used is TCP source port, that could be any port, and the destination, the port which I am serving is a 80. Allow HTTP traffic from all over the world, adding this rule. Okay, done. Now we can access our compute instance in the web page and we can see the index page that we have created. Here it is. There is a web 2. Okay, we will have 10-minute break so that you could complete till the compute instance, creation of a compute instance and starting the web service. So guys, if you have any issue, just ping us, just do it. And if you have completed computing the com cre creating compute instance and the web service, then just ping us with the message done. Just ping us if you have any issue. We will wait for next 5 minutes, right? Uh, Virat, I think you already have two compute instance over there. So if you want to create the compute instance with the shape pm.standard.2.1 micro, then you need to delete them. You are allowed to create only two instance with this shape. Means if you have more than, if you try to create more than two compute instance with the always free eligible shape and size, then you will get this error. So either you can select the different compute instance or the different compute instance shape, or you have to delete the existing one. So Virat, if you can see my screen, then if I create the same thing, I have already two instance with always free eligible. So if I try to create the new one, then I will get the error. Look, did you notice? So in this case, either I can go with the different shape and size. So if I go with the different shape and size, then I can able to create the and just click on create. Yeah, I'm able to create. Ping us if you are able to create it or you happen to have some issue. So Ujjwal is asking, can we use E2.1 micro and E1? You can use any shape and size that is available to you. So it is not mandatory to use the exact same shape, because we are not doing some heavy load type of the issue. So we are basically creating a web server. So it doesn't matter the shape, whichever the shape you choose. So I'm not interested in Web3. So let's terminate it. And if you are terminating any instance, just make sure you check this permanently delete the attached boot volume. Otherwise, you will get the boot volume list of the boot volume preserved. So, and I think if you are doing any test, then there is no meaning to save the boot volume. So just terminate instance. Okay, guys, we have it in our hands-on lab guide, so you may follow up it anytime. You can go through it anytime, and if you happen to have any issues, then you can ping us anytime. You can ping me, you can ping Romy anytime for the any issues. So let's move ahead. So we have created two compute instance and installed Apache over there, and we can see this is web and this is web 2 message from the different servers, right? So after that, we will configure a load balancer. For that, just click on navigation menu, click on networking, click on load balancer. After that, click on the create load balancer. You can change the name of the load balancer. If you are happy with the default type, you can leave it. Let's say it as a lb underscore web. And we are going to create a public load balancer, right? So basically we are hosting two web servers and we are accessing it from the internet. So we need to set the visibility as a public. And we are happy with this traffic. You can even downgrade the traffic. I'm happy with the 10 Mbps also because it's a simple website. So, and select the VCN that is being created at the first step. Select VCN and create select the subnet that is being used for the public load balancer. After that, create on next. These are steps are listed over here, VCN and public subnet. Click on next. Now we have a policy, three policies, that is weighted round robin, IP hash, and list connection. So in our case, we are happy with the weighted round robin. So just select it. After that, we need to click on add backend server. So this is where we define where the load balancer should route the traffic to. So in this case, add backend, click on add backend. You will see here compute instances. Just click on them, select both of them, and click on add selected backend. After that, we have a health check policy. So basically, we will do a HTTP. We will use protocol as a HTTP for the health check. Port that is being used is 80, and intervals is 10,000 milliseconds. So every 10 seconds it checks for the health, and timeout value is 3,000 milliseconds. That is it waits for the 3 seconds, and if didn't get shut, then it will declare timeout. And the status code that it should return is 200. That is the status okay. And URL path is slash, and the number of retries is 3. It basically tries for 3. After that, click on next. Now the step to configure the listener. So in this case, we will change the listener's name to listener underscore web. We will listen it on the HTTP. So basically our load balancer will listen on the HTTP rather than the HTTPS or TCP. So HTTP, then port by default is 80. So after that, click on submit. Now it is in the creation process. and overall health is unknown because it have not checked it yet, and the backend set health, the health of the backend server is also unknown. It is not able to check it. It haven't, if it has not checked it yet. It may take around 2 or 3 minutes to fully configure load balance. Yeah, it is active now. Now, once it is active, just copy the public IP address. Now it returned this is web 2. Just refresh it. Okay, it's this is web 1. Now it is serving from web 1, and if we refresh it, it get to the web 2, web 1, web 2. Yeah, this is the